Hello, I'm Professor Von Schmohawk, and welcome to YU. This series of lectures is an introduction to algebra. But before we discuss algebra, we should start by taking a closer look at the things we call numbers. In even the earliest cultures, understanding and communicating quantities has been essential to everyday life. Anthropologists tell us that even the most primitive Stone Age cultures had some concept of number. However, early number systems were much more limited than today's base 10 number system. Life was simple back then. We didn't need names for exact quantities. If you knew that there were a herd of gazelles nearby, it didn't matter exactly how many gazelles were in the herd or exactly how many miles away they were. What was important was that there were a lot of gazelles and they were just over the hill. Even recently, certain Australian Aboriginal tribes counted only to 2, with any number larger than 2 called much or many. South American Indians along the Amazon had names for numbers up to 6, although 3 were called 2-1, 4 was 2-2, and so on. Bushmen of South Africa had a similar way of naming quantities, but stopped at 10 because the names became too long. This tribe would not do financial transactions involving numbers greater than 2. For example, they would not trade 2 cows for 4 pigs. Instead, they would trade 1 cow for 2 pigs, and then in a second transaction, trade another cow for another 2 pigs. If you had never heard of numbers and you want to describe to someone exactly how many gazelles you had seen just over the hill, you might use your fingers to represent how many gazelles there were. Of course, this would become difficult if there were more than 10 gazelles. You could cut marks on a stick or maybe gather a group of pebbles to represent the number of gazelles. But then this would also become cumbersome if there were a lot of gazelles. Another option would be to invent different names and symbols for each possible quantity. This seems like a simple solution, but there is still a problem. Remember that you know nothing about our modern base 10 number system, which uses only 10 symbols in different combinations, so you will have to invent a new word and symbol for every possible quantity. For instance, in my primitive tribe on Coco Loco Island, here are the first 30 numbers we use. Zoop, Bloop, Dop, Trom, Mim, Zap, Weenie, Glumby, Bimpy, Michi, Frump, Wacket, Trimble, Wallakai, Kravitz, Jolo, Ponzo, Kolib, Krub, Wallop, Zumi, Mombozo, Bellimi, Toramu, Balazit, Smip, Bazulu, Ikina, Ichiwa, and Zoltan. After Zoltan, we just say a whole bunch. There were several problems with this number system. First of all, since we had over 30 symbols to memorize, math was really difficult. For instance, if you have Wallakai coconuts and then you eat Mim coconuts, how many are left? The answer is obviously Bimpy coconuts, but it takes many years of school to memorize all the combinations. Also, what happens if you have Bazulu coconuts and then someone gives you Trom more? Well, then you'd have a whole bunch of coconuts. In the past, some of the mathematicians on Coco Loco Island actually invented an advanced number system with several thousand names and symbols to handle problems like this. But as soon as they did, someone always came up with a problem which they did not have a number for by adding Zoop to the biggest number. Then, one especially brilliant Kokolokian mathematician came up with the idea of combining symbols. After Zoltan, the next number would be Zoltan Zoop, then Zoltan Floop, and so on. When you got to Zoltan Zoltan, you then would go to Zoltan Zoltan Zoop, and Zoltan Zoltan Floop. This worked well, but numbers could get quite long. For instance, our number 1000 in Kokolokonian would be Zoltan 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 Nietzsche, which we would write as. After many years, people realized that it wasn't necessary to write Zoltan over and over. The first symbol could just represent the number of Zoltans. For instance, the number Zoltan, 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 Zoop would be Dop Zoop. 3 Zoltans plus a Zoop. Zoltan, 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 Zoop would be Trom Zoop. 4 Zoltans plus a Zoop. The first symbol could represent up to Zoltan Zoltans or 900. This 2-symbol system still couldn't quite get up to 1000, but nobody had that many coconuts anyway. Then one day a boat arrived from the distant island of Bongo Pongo. We were all amazed. The Bongo Ponganians had invented a much better system which could represent really big numbers with much fewer symbols. Apparently, in early prehistory of Bongo Pongo, they must have counted on their fingers because they only used 10 different symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0, which they called fingers or digits. They counted up to Bimpy, which they called 9, using a single digit. After 9, they used 2 digits. The first digit represented some number of tens, and the second digit would add from nothing to 9 to that. For instance, the number 32 would represent 3 tens and 2 ones. The number 47 would be 4 tens and 7 ones. Likewise, the number 80 would be 8 tens and 0 ones. But here is where their number system was really amazing. After getting up to 99, you would think that they would have to stop. But no! They would just tack on another symbol in front, which would now be used to represent hundreds. Yeah! This could take you all the way to 999, which meant 9 hundreds plus 9 tens plus 9 ones. Every time they got to the biggest number they could represent, they would just tack on another digit which represented the next bigger number and kept going. This system had some big advantages. First of all, there were only 10 different symbols to remember. Secondly, every time they added a digit, they could represent a number 10 times bigger. So with 6 digits, they could represent almost 1,000,000. That's a lot of coconuts. Looking back, it is easy to see the problem with the first Kokolokian number system. Each quantity required a new symbol, so when you ran out of symbols, you ran out of numbers. With 30 symbols, the largest quantity that could be represented was 30. The second system allowed these symbols to be combined in a single number and their values added. But since each symbol could add no more than 30 to a number, numbers got big really quick. The third Kokolokian system could combine 2 symbols, one of which was multiplied by a factor of 30. This allowed larger quantities to be created with only 2 digits. However, the largest number was still less than 1,000. On the other hand, the Bongo Ponganian system used only 10 symbols. However, with just these 10 symbols, very large quantities could be represented with just a few digits, since each additional digit in a number represented a quantity 10 times bigger than the previous digit. This system was simple and efficient, and the quantities that could be represented were unlimited. That is why this is the number system that the world uses today.